Hey guys, how are you doing? I hope you all had a really good Thanksgiving break. I hope you got to do something you enjoy. I know I was pretty lazy, got to sleep late, so that's just the best thing I think for me. So, okay, today we are going to move on and we are beginning Unit 5. So that's where we're going to start is putting our journal slides for Unit 5. And you're going to find Unit 5 is a really short unit. I think it's going to be a pretty low-key unit. It's not real difficult. There's not any like majorly hard things in Unit 5. So I think for the most part, students usually enjoy Unit 5. So let's take a look in Canvas. So if we go to Canvas, go to the modules page. Now yours won't say sandbox up here. Yours should be the actual one. Okay, so if you go down to Unit 5, remember you can collapse. I've unpublished some of the modules, but remember you can collapse these. If your modules page is getting too long, go ahead and collapse these. And scroll down to the bottom. You're starting with the video. So you can pause the video right now and go open up your Algebra 1 journal, the one you've been working on this 9 weeks, the one that has the blue cover. So pause the video right now, go open that. Okay, and then come back over here and let's go put in the journal slides for Unit 5. There's not that many, so we're going to click here. And we're going to go ahead and fill in our table of contents and everything. So let me show you how to copy more than one at a time if you've forgotten how to do that. Let's get it to load real quick. So as you can see, I have clicked on the first one. It should be highlighted over here. I'm going to wait and see if it'll load all the way. Okay, so the top one is highlighted. So you're going to scroll down, but I have not clicked the bottom one. Before you click the bottom one, hold down the Shift key on your keyboard, and then click the last slide, and then let go completely of everything. Let go, I'm not touching anything right now. Now you can right click and hit copy. Or for you guys on a Chromebook, you're gonna have to click with 2 fingers to get that copy to come up. Then come back over to your journal, and I'm just going to go down to the very, very last slide. Should be slide 21. And you can right click again and paste, or you can hit Control V, and it should paste them all in. Remember, we hit do not link. Okay, so there were only 5 slides that we were adding. There's our objectives for Unit 5. So let's go fill in our table of contents. Notice there's only 2 lessons that we're actually putting in the journal. So if I come up here, I'm going to zoom in. Remember, that's too much. You can pause the video whenever you need to. So the first one's going to be Unit 5, Lesson 1. And we're going to call this one Systems of Equations. That's pretty much what we're talking about in Unit 5, is systems. And then Unit 5, Lesson 2, we're going to call this one Writing Systems of Equations. Now let's link it. Let me come down over here. I think this should be 23. So this first one right here, I'm going to highlight all the words, hit the link, and I do slides in this presentation, and then I'm looking for slide 23. And then I hit apply. Boom. This one should be linked to slide 25. Link slides in this presentation. Remember, for you guys, sometimes it won't scroll down, but you can use the arrow down key. If you start arrowing down, it usually will let y'all see the rest of your options there. Okay, so there we are. We're linked up. So today, your objectives, notice there's really not that many objectives in this unit compared to what we have had in the past. So this is what we're going to learn. We're going to learn to write systems. We're going to learn to graph them. We're going to learn to estimate them graphically, which is real easy. We're going to learn to graph the solution set of inequalities, and then we're going to learn to solve systems, then like real world problems. So, but really all that stuff kind of fits together. So what we're going to do now is I'm going to bring up another slide and I'm going to let you know, like, we're going to kind of introduce systems. What does this even mean? This should be completely new terminology. We're going to come back to this slide right here in just a minute. But for now, just kick back and watch the video. And so let's talk about what are systems of equations. What does that even mean? Okay, and we're going to talk about solutions to systems of equations a lot too. Before we do that, let's go back and review what we know about just equations in general. So here's an equation. X minus 1 equals 5. So I want you to think, can you think of a number, a solution for X? Remember, a solution, it means it's a number you could plug into that equation where X is sitting and that statement would be true. So what I'm asking you, is there a number that you could subtract 1 from it and get positive 5? I hope so, and I hope that you're all thinking, yeah, we could do this. Now, you probably know the number already. Remember, we can go through and use our steps and we could solve the equation. We could draw a line. We added 1 to both sides. Well, it would cancel out on that one side, and we would be left with X equals 6. I hope that's the number you were thinking of anyway, right? This is pretty simple. 6 minus 1 is 5. Duh. Okay, so that's what a solution is to an equation. So now I want you to think of this equation, because this one's different. No longer is there just one X. Now there's an X and a Y. So X minus Y equals 5. So basically what this is saying is I have 2 numbers now. I have one I don't know, I'm calling X, and another number I don't know, I'm calling it Y. And when I subtract them, I'm getting 5. So X minus Y equals 5. So some number, take away another number, and I'm getting 5 when I subtract the 2 of them. Can you think of a solution to this equation? I mean, right now what's popping in my brain is 10. 10 and 5. 10 minus 5 equals 5. So X could be 10, Y could be 5, and 10 minus 5 would be 5. Actually, and that's true, there are a lot of solutions to this equation right here. Look at all of these number combinations. 6 minus 1 is 5. 10 minus 5 is 5. 5 minus 0. 15 minus 10. 8 minus 3. And you know what? There's an infinite number of solutions here to this equation. And so I'm going to show you a picture of every single one of the combinations of numbers that when we subtract them, we get 5. So here it is. Here's a graph for every single solution. It's a line. This is what lines are. And when we graph lines, we have points that are actually on the line. Those are your solutions to the equation for that line. I don't know if that's ever clicked with you before, and I know I've mentioned this, but we haven't spent like time just really thinking about it. But this is important. So the graph for this line is every single point, the combination of numbers that when we subtract those 2 numbers, we get 5. X minus Y equals 5. That's why the solution is a line. All the points on that line are numbers you could plug in for X and for Y. When you subtract them, you'll get 5 every time. Even all the way down here, 0 minus, see, that's what it's saying, negative 5 is positive 5. Well, if that's true, then let's think about this. What if I have 2 equations, okay? So now I'm looking for 2 numbers over here on this side. When I subtract them, X minus Y, I get 5. So one number minus the second number, I get 5. And when I take those same exact numbers and I add them together, I get 15. So think in your brain right now. Pause the video if you want to. See if you can figure out the 2 numbers. Are there an infinite number of those combinations again like we just saw before? We know there's an infinite number that when we subtract them over here, we get 5. But can we take those same 2 numbers, such as 8 and 3 was one of them. So 8 minus 3 is 5. But if I say 8 plus 3, do I get 15? So now I'm looking for a solution that works for 2 equations at the same exact time. I have the numbers right now. I am thinking of them. Maybe this is what you're thinking of. 10 minus 5 equals 5. And if I say 10 plus 5, I get 15. There's my 2 numbers, 10 and 5. So let me show you what that looks like on a graph. So remember, we've already seen the graph of X minus Y equals 5. That's the green line again. And now I've also graphed X plus Y equals 15 on the same exact graph. So notice here what's happening with those 2 lines. They are crossing each other. And guess where they're crossing? Boom, at 10 and 5. Because remember, all the points along the green line, X minus Y equals 5, are all solutions for that one. And then the same thing, all the points along the red line are also going to be solutions for x plus y equals 15. But there's only one point that the two lines have in common that would be solution for both of them at the same time. So this is a system of equations. It just means you have two lines now, and we want the ordered pair that's a solution for both of them. And every single time it's going to be where the lines are crossing each other, because that's the only point that they have in common. So if all the points on a line are solutions for that particular equation, well, then the point has to be common between both lines for it to be a solution for both of them at the same time. So we're going to summarize this in our notes here. So go, as you're watching the video, either do your screens, split it side by side so you can type in your notes, or watch as I give you a piece and then go back and type it in. You're going to be filling in this top box here in your notes, okay? So what is a system? Let's define it. It's two or more equations with common variables. So that's it. We've been looking at equations that are just one. We've had one equation. Well, now we're looking at two at the same time. And they have to have common variables, which means you can't have one equation that has x and y and another one that has, I don't know, a and b as variables, because they're not the same things. They have to have the same variables. So pause the video and go fill this in your journal right now. Okay, so what are the types of solutions? Well, there are actually several types of solutions. There could be one solution that's intersecting lines. And I'm going to show you a picture of that, and you already have this picture in your journal for you. So one solution would be right there, boom, where they're crossing each other, that point. That's the solution. So if you have two equations and they cross each other once, that's one solution. So make sure you type this in your journal. That one solution is when you have intersecting lines. Now, you could have no solution, and this happens. You have this picture as well. What if I graphed my two lines and they were parallel? So let's think about this. Do parallel lines ever cross each other or ever intersect? No, because we've talked about how that's the definition of parallel lines. They don't ever intersect. Because they never intersect, there are no points in common, which means there are no two numbers that would be solutions for both equations. It's absolutely impossible to find two numbers that would work. That's parallel lines. So they never cross. There's absolutely no solution for that system for two equations. There's no two combo of numbers that's going to work as a solution to both equations. Now, we do sometimes have something that we call an infinite solution. And you'll see this a lot when you're graphing it. So you'll graph one line, boom, there it is. And then you go to graph the second line and it's right on top of the other one. And you'll be like, where'd the other line go? It's actually underneath it, because what you've done is you've actually graphed the same exact line. And so we call that, if you have a system where it's the exact same line, it's still two equations we had. They just happen to make the same picture, the same line when we graph them. But actually one equation is going to be a multiple of the other one. We say there's infinite solutions. It doesn't matter. Absolutely every single point is going to be a solution, because every single point is on both of the lines. They all have every single point in common, so therefore there's infinite solutions. So that should fill out your that journal right there. Let me go back up here. This page right here. So now you should have this filled out. I'd already given you the pictures. So now what I want you to do is go back to Canvas, and you can hit the next button if you're on the modules, if you're still on this slide, or if we go back to the modules page, I'll show you. So my screen is a little bit different because I have all four of these listed. That's because I'm the teacher, even though I'm in student view right now. You should only have one, depending on which period you're in, or if you're at home. So you should only have one that's showing up. If you have two, don't worry about it. Just click on the one that's showing up for you. Click on one of them. I don't really care. So I'm not at school this afternoon. So if you're in 6th, 7th, or 8th period, you're going to complete this activity. I don't mind if you partner up with somebody and work with a partner on this. That's completely fine. If we're at home, you're going to be working on this at home. So you're going to click here, and it's going to take you to a Desmos activity. Now you should, it's like this one. You should get this screen if you have already signed in with Google. If you have never signed into a Desmos activity, Or it could ask you again, you want to click log in with Google and then click go. So what's going to come up is this right here. So these are examples of systems of equations and talking about how do you find the solution. It's kind of really an interesting little video here. It's kind of funny. So watch the video, go through the activity. It's kind of a discovery thing where you don't really need me to sit here and walk you through it. Like, it gives you prompts. It tells you exactly what to do. You're kind of trying to discover. If you're going to figure out what is that solution to the system, remember, that's where they're crossing. What's the best way? How do you think would be the best way for us to find that solution? There's a whole lot of ways for us to find the solution to a system of equation where that's that point they have in common, those two numbers. So go through this today. See what your thoughts are. It's going to ask you to kind of explain some of your thinking. So remember, there's no right or wrong answers to your thinking. Just give me what it is in your own words, what you're thinking about the questions that it's asking you. And then tomorrow we're going to come back and we'll actually, I'll show you what I think is the best way to find the solution to a system, and we'll practice that.